for today, we're going to focus on cloud and autonomous database. And so the first part of what we're going to do is just give you a little overview of my view of where the world is around cloud today. So, a lot of customers have already started dabbling with cloud and making strategic decisions. And the SaaS market is really the most mature part of the cloud market. A lot of your companies already are running SaaS applications, business applications over the internet in the cloud. This market is really mature. If you look at, when did Salesforce.com and NetSuite start? It was 1998, and they had their first products out maybe a year later. So this is 20 years old almost, that market. It's very mature. The revenue is quite large, $74 billion market. Oracle has a very mature offering in the cloud now. We're considered a market leader there. So lots of data in the cloud, in Oracle databases, running on Exadatas, supporting all of our SaaS fleet. Okay, the next big thing that came for cloud was infrastructure as a service. And of course, this was started by Amazon AWS back in 2006. And again, this market is pretty mature now. That was 12 years ago. The market size is now about $40 billion. And the market has really narrowed down. There are only really 6 players left in this whole cloud infrastructure space that the analysts even follow. Oracle's one of them. The interesting about this market is a lot of customers are making decisions on what cloud vendor to use now based on infrastructure, okay? And infrastructure, compute and storage, it's important stuff. But what's really important is your data. All the customers I talk to now are saying, oh yeah, we're going to be a data-driven organization. Data is our key asset for our company. We're going to leverage that data for competitive advantage. Okay, so of course most of you are using Oracle databases today on-prem to store and manage and protect all your most critical data assets. And what we want to talk about today is why the best choice for you as you go to cloud, where data is so important to your organization and moving forward, why you might want to consider Oracle as one of your strategic cloud vendors. And I personally think, of course, data is much, much more important than just vanilla compute and storage. That's all commodity stuff. So moving forward, I think as you consider cloud vendors, you should take a look at us. Okay, so what are we doing there? Let's talk about sort of the big picture of what we're rolling out in the cloud. So first of all, there's persistence for data, right? There's basic storage. The object store on clouds provides support for sequential files, block stores. You might still use HDFS on the cloud, although on the cloud, object stores are pretty much taking over the role of what HDFS does on-prem. And then as you go to data management, of course, we have our autonomous databases, autonomous data warehouse, autonomous transaction processing. And then we also have a NoSQL offering that came out early in August, where for customers or developers that really like the model of simpler data management with NoSQL access, we have that as well. And then finally, of course, Oracle has MySQL group, and we are in the process of actually revving that MySQL service we have in the cloud, because lots of developers like using MySQL as well. Okay, so that part of what we're doing in the cloud is pretty much all there. So what's the vision part? Well, the vision part is what we want to do for you is something you really have never been able to do on-prem, which is to make sure that all those data assets you've got in the cloud are cataloged. So if your analysts want to get at any kind of data, they should be able to easily find it. And then they should be able to use any form of processing against that data as if the data was just in one virtual pool of information that's your company's key asset. So things like SQL access. We have a technology called Big Data SQL. We are going to roll that out on our cloud so you can have SQL access to all the data. Whether it's in the object store, Oracle database, NoSQL database, you will be able to get at it very easily. Okay? Machine learning, AI algorithms. Of course, we have those algorithms built into the database now for like 15 years, But a lot of analysts will also be using things like open source algorithms, Spark algorithms, for doing machine learning and other algorithm analysis of their data. So we want to support that, of course, across all the data. Again, whether it's in the object store or the database, it should all be accessible to your analysts. And then we'll be rolling out other services based on some other technologies we have. Oracle Spatial and Graph already is available on-prem. We also have made that technology available on-prem against HDFS data in the Hadoop world. And again, we want to bring that into the cloud as a service so you can use graph and spatial algorithms against all your data in the cloud. Okay. So just at a high level, the big vision of what we're trying to do here is make all that information your organization's capturing available to all the analysts really easily via metadata catalog, and then run any kind of processing against it that you want, any kind of analytic algorithm, predictive analytics, machine learning, SQL, all should be easy to do. Okay. Okay, so I'm going to focus in now on what we're doing in particular around autonomous database. And I'm first going to reintroduce this. A lot of you already know this, but a lot of you probably don't. So the vision here is pretty simple. We want to eliminate all the need for human labor to sort of provision or patch or upgrade or operate in any way your Oracle database, tune your Oracle database, et cetera. Okay, so that is the grand vision here. And we'll talk about where we are in this vision, and we're doing really well, I think. So number one, we call this autonomous database because the word autonomous has been used pretty successfully now in the car space. People talk about self-driving cars as autonomous cars. And it turns out what we are doing is very analogous to what people are trying to do with cars. And so we're trying to make a self-driving database. That gets at the core of trying to eliminate the need for human labor around the database, right? We're going to do all the, manage all the infrastructure for you. We're going to manage the database software itself. And we're going to add a layer of autonomous self-tuning on top of that, okay? Self-securing, we're going to take over responsibility for making sure your systems are secure. We are going to take the hassle away from you of applying these constant streams of security patches that you have to deal with today, okay? And then self-repairing, that just means we're going to implement all of the MAA technologies we've been developing over the last 20 years, using our best practices and all the latest and greatest best practices, okay? And we're going to provide a very unique SLA, if you want it, that'll let you not, rest at night. We will take care of making sure the system is up 99.995% of the time, even in the event of planned maintenance, okay? Okay, so for the next couple of slides, what I'm going to do is sort of like Autonomous Database 101. And the way we're going to do it is basically draw parallels to autonomous cars, between autonomous cars and autonomous databases, okay? So let's just go to that. So when you acquire a car, what do? You want to figure out first, what is the use case for my car? Am I going to be driving up to the mountains in the snow, so I need four-wheel drive SUV, or am I going to be having fun, driving along the coast with the top down, and want a fancy sports sedan? What is the use case? And then you figure out things like, what is the model you want, what's the color, the interior and the exterior, all that kind of stuff, right? On the autonomous database side, the equivalent of what you're doing is what in the cloud space people call provisioning. You want to provision an autonomous database. And the first thing you have to tell us is what's the use case again? And we have two use cases. One is analytics use case. So I have a database primarily used for analyzing large amounts of data. It's a data warehouse, data mart, something for my data scientists to use, or some kind of big data lake for storing lots of information, right? And then the other big kind of database workload use case is transaction processing, or general purpose mixed workloads of transactions and analytics, right? So you tell us that, what's your use case? And then you just tell us some simple things like how much compute you want. I want 10 CPUs and 20 terabytes of storage. And of course, all that can change as you go along. And That's about it. So provisioning an autonomous database is really easy, just as easy as buying a car. Now, how do you pay for this? So on a car, you pay for it by, you pay money, you get a lease. And maybe in the future, the car companies are going to go into being like an Uber kind of service where you might pay as you go as well. And then on the cloud, of course, the big reason people love cloud is the economics of cloud is you pay as you go. You don't have to pay up front for all the hardware that you might need only for the peak period at the end of the quarter. You just pay as you go, right? And so that's the big key to the economics of cloud. And of course, we support that with our autonomous databases. OK, so that's how you acquire or provision a database. Now, what about operating the database? OK, so with a car, people are starting to come to the point where an autonomous car will let you just say, OK, you hop into the car, you tell it where you want to go, and it will do hands-free driving someday and get you to that point in time. And then those of you who drive these cars out there, that are out there today, no, it doesn't quite do that quite yet. So with autonomous database, it's very similar. What our vision there is, you just tell us what tables you want in the database, so you still have to do data modeling. And then you just load your data and run the queries, and you're done. OK, so it's a load and go kind of experience. So that's what we're trying to do with database. And then for maintenance, of course, and with cars, if you want to get your car fixed, in almost all cases, you have to go into the shop and you have downtime, right? Your car is not available while it's getting fixed. With autonomous database, on the other hand, we are trying to do all maintenance online. As I mentioned, we're going to provide this SLA where we will guarantee 4.5 nines of uptime, which equates to about 2.5 minutes of downtime per month at most. And this is a true SLA in face of all kinds of failures. If there's a bug in our software, that counts. This is not like all the fake SLAs you see out there in the cloud where they say, yeah, if there's a bug in Postgres, that's not our software. Why should we take a penalty for that? We take responsibility for everything in our SLA. Right? And then finally, if you want to upgrade a car, well, there are a few cars out there that do online software updates, but that's about the best you can do. If you want to make it bigger or faster or whatever, that's not going to happen with a car. But with our service, of course, if you want to ever grow it, you want more storage, you want more compute, you can do that online at any time. We also have this thing we call instant elasticity, which again, if you're going away from work, work on the weekend and nobody's going to be around doing anything, all you want to pay for is the storage, right? You don't want to pay for the compute anymore. You want to pay as you go. So we let you do things of that sort. And again, that drives down costs of the cloud service. Okay? Okay, so when we started talking about autonomous database to customers, it was really nice for me because for years we had been talking about cloud and I would see the customers in the room and they're like yawning and reading their mail and they just weren't, our enterprise customers especially were not real interested. But when we started talking about autonomous database, I see a huge amount of interest, starting from the top down in the organization. So the CIOs in particular really love the concept, right? It's really, they love the low cost and they love the low risk. If you already have all your key data assets on-prem in an Oracle database and you can just move that to a cloud, that takes away the whole nightmare of how do you rewrite everything so it can run in the cloud. You don't have to do that with Oracle. There's very low risk to moving to Oracle database in the cloud, right? Compared to migrating to some other incompatible service, right? And they, just looking at our 3 key attributes of cloud, the CIOs love the self-driving. When we take over management of all the infrastructure for them, that's great. It lowers all their costs. They like the self-securing. They don't want to have to answer to the board of directors about why their organization did not have the latest patches applied, and that's how the hackers got in and stole the data, right? That's our problem now. They love that. And then finally, the self-repairing part, just keeping the system up and running, their most critical systems up and running all the time. We're going to commit to doing that. We're going to give you an SLA. CIOs love that as well. So I think, and we'll talk about other people in the IT infrastructure, but in general, we're getting really good response from customers. They really like this concept, so we think we've really, hit on something that is resonating well with you guys. Okay. So how did we get there? Well, autonomous database service doesn't just appear out of nowhere where we did a few months of coding and voila, we're in production. We're building on top of technology that we've been working on, in some cases, for over 20 years, right? In particular, the infrastructure under this service is going to be Exadata. We started working on Exadata about 10 years ago, and Exadata today is by far the best platform for running all workloads on Oracle databases, whether it's an analytic workload, transaction workload, or everything in between. And we have a huge number of customers now using Exadata on-prem. And actually in the cloud now, one of the interesting statistics, if you look at the Fortune 100, the biggest 100 enterprises in the world, 25% of them are now running Exadata either as a cloud service in Oracle's cloud or via Oracle Cloud at customer. So we're getting good traction in general around Exadata. Okay. The next big element here, of course, is our software. And we've been, again, working on making the database software automated in many different dimensions for many years. This goes back to the early 2000s. So 15 years ago, we started this thing we called server manageability. And we built things like AWR into the database where we capture all these statistics about what's going on in the server so you can do performance diagnostics. We created things like ADM. All those technologies are, of course, being built on top of to make autonomous database work. Things like SQL plan management, the query optimizer, very mature technologies are all key for autonomous database. Okay. And then the machine learning part. So this is a more recent work in the development organization. The Exadata box itself, we've been automating detection of failures in the hardware for a number of years now. So whether it's detection of failure in the compute, storage, the network, we will automatically deal with it as we discover it. In the database, we've had some technologies, more recent technologies, again, for looking for anomalous behavior in the database, predicting something's going to fail, and then doing something about it. We have machine learning algorithms also that when there is a failure, we actually will look at the signature of the failure and we can go straight to the bug database and actually look to see if there's already a bug report on a problem that matches the failure. And we automatically will identify the bug, we'll automatically find the patch for that bug and give it back to the customer. And then the big thing we're doing that really has just started as part of this autonomous database development initiative is around workload optimization. We have very mature technologies for query optimization. That technology works well and it works best when it has statistics that are accurate and have the latest data distributions for the data in your database. And to do that, we have now added what we call real-time statistics, which means as you are updating your data, we are updating statistics in real time. And by doing that, the query optimizer has the best data and it's going to choose the best plans. I mean, it's very simple. On-prem, it's been your responsibility to make sure the statistics are reasonably fresh. On the cloud, we are going to do that automatically for you. And then finally, on top of that, we've now built an expert system that does automatic index selection for you. This is now just going into beta. It's part of the new autonomous transaction processing service new version that's going to be rolling out probably early next year, but it's going into beta now. And this is a really amazing technology. So we'll talk a little bit about this more later, but our query optimizer group is sort of figuring out with an expert system, it captures all your workload that's being sent to the database, all the SQL and PL SQL statements, and it is continuously trying to tune your system to make the performance better. And I'll talk about that later, but this is sort of the key new technology we're adding in to the autonomous database service. Okay, so let's drill down a little bit into what's Autonomous Database. We have these two services I mentioned, one for analytics, we call the data warehouse service, and one for transaction processing and general purpose workloads that we call Autonomous Transaction Processing, or ATP. We first shipped the data warehouse last March, so we actually have a lot of production customers now there. Autonomous Transaction Processing, much newer service, not as much production customers to report there, but we're going to have a lot because that workload is much more common. Probably 80% of the workloads fit what you'd run on Autonomous Transaction Processing. 20% are more pure analytic style workloads that you'd run on Autonomous Data Warehouse. Now, what are we doing at a high level from a technology standpoint to make these two services work well for their different style of workloads? Well, Oracle is a very unique database technology that works across basically the whole spectrum of use cases that you have for data management. And the way on-prem that you have to deal with that, you have to sort of say, okay, I'm doing a big data warehouse, so I'm going to configure my system a certain way. And if I'm doing a transaction processing system, I'll configure it a little differently. So in the cloud, we are doing this for you. And so for the Autonomous Data Warehouse, we take the Exadata box, we turn on the flash cache with the in-memory columnar caching in the flash cache. We use hybrid columnar compression for all the tables. And we have a system then that's well configured for running your massively parallel query workloads with really good response time. Okay? So that's what Autonomous Data Warehouse does. It's fully self-tuning. It can do all the workload tuning already in the current version. Okay? Autonomous Transaction Processing, different kind of workloads, right? Here you have short transactions. You want to optimize response time. And the way you do that kind of optimization is by figuring out what indexes to choose to get the queries that have to look up by key to run really fast, right? You use a row format for the data. That's the right format for doing transaction processing, where you look up a row by key. You want to bring the whole row back. You don't want to use column stored technology. It would be really slow. Okay? And so the key thing here is how do you create the indexes? And we'll talk about our autonomous automatic index creation technology a little later. Okay? So these are the high-level technology differences between the two services. Okay? So let's drill down a little bit more into Autonomous Data Warehouse, ADW. So there are three major things we sort of talk about here. Number one is easy. This system is a real load and go system. You just tell us the tables you want to create. So you need a data architect to create the data model, the star schema or whatever it is that you have for your analytic data. And then from then on, your developers just load the data and send us the queries, and we process them. There's no need for any other labor with the service. Okay? It's very easy to use. All the complexity of all that Exadata infrastructure and Oracle database infrastructure, it's all hidden from you. Okay? It's very low cost. Again, we take care of all the administration for you. We do self-tuning. We have this instant elasticity. So, if your analysts go home over the weekend, or they need to, they can take down the compute to 0 while they're gone. Just store the data and just pay us for storing the data. If there's this big workload you have to do to close your books at the end of the quarter, you can scale up the workload. Again, instantly, go from 16 to 32 CPUs or whatever, okay? So very elastic service. And by the way, this is in contrast to what you'll see in other clouds. If you look at Redshift, they provision physical, they call it shapes. You can't scale up at the end of the quarter without moving all your data to a new shape. And they try to make it easy for you, but of course the service is not, you can't update the data while they're moving everything around, okay? And then coming soon, there are a couple areas we haven't fully made autonomous yet. And in the data warehouse space, the big thing customers like doing is they like doing what we call rolling window management, which is you've got this new week's worth of data, and you want to roll it into the database, and you want to roll out the week that's a year old out of the database. That's what we call a rolling window. We are in the process of making that a fully autonomous operation. In the meantime, the way you do this is with partitions, and we make it possible if you want to do manual partition management with the current service, you can do that already today. And then finally, I mentioned this thing about instant elasticity, where we will say, okay, you can take your CPU down to 0, or you can double the CPU. So what customers have asked us for is it's great that they can call an API and change the CPU or storage, but why don't we do it automatically for them, just like an operating system would do? And so we're going to let you give us a min-max for the CPU, where you'll say, okay, the min is 2 CPUs, the max is 32. Just scale up and scale down depending on what my workload is. You take care of it for me. So that's the next thing we're going to make fully autonomous. Okay? The use cases for this service are the traditional analytic use cases, everything from traditional business analytics systems to machine learning. We provide your data scientists with a notebook environment where they can do their data science to create the models, and they can then sort of deploy the models on ATP. And then we also integrate very closely with our object store. So if you want to create a data lake where you want to throw in lots of data, semi-structured data into files, you can do that with our object store. The object store is completely integrated with ADW, and we can run SQL. So if you want to do ETL in our environment here, you just load your next batch of data into a file in the object store, and then you can just use SQL. Insert into my table, select star from the object store, insert the new batch of data. It's very simple. So it's all integrated. So we have SQL working across all of the data in your ADW database and the object store. Okay? And so one of the things I like talking about here is so although we call this autonomous data warehouse, this is not just a data warehouse. It also moves into it has the flexibility of what people value in what people call big data platforms. We can support all of your data, whether it's for high performance interactive querying or for creating data lakes. You don't really need a big data platform anymore in the cloud. You can just use ADW and the object store to do everything you might do with these so-called big data platforms. Okay. Okay, this is just a little detail on, one of the new kinds of users we're looking for here are the data scientists. Traditionally, data scientists tend to not use databases. They're using, all kinds of tools to pull data out of various data stores and doing their thing, outside of the database, which, that's fine. They can still do that. But we also give them an environment here where they can create their machine learning models and then later deploy them in their transaction processing databases. As I mentioned, we have a lot of customers, and I just wanted to call out one here that's using the machine learning technology. QLX is a company that partners with a lot of sports teams, in particular like the NBA, and they collect lots of statistics from these sports teams, and they are using ADW, and their big win here is they can get their data loaded really fast and get valuable insights back to the teams much, much faster than it was possible before. And I give an example of a couple of the machine learning algorithms they're using today. So one is they're trying to figure out which fans are going to be the most likely to renew season tickets. That's a key business, kind of thing that the NBA teams, of course, want to know, or any sports team wants to know. And the other thing, of course, is just like your business. They want to figure out which customers are going to spend more and identify them and market to them. Okay, so now what we're going to do is, I mentioned there's a lot of customers running ADW. We're going to run a short video that goes through some of the customer use cases. Thanks.
When you're dealing with human lives, time is everything. It could be a matter of life and death. So if the autonomous database cloud can actually update itself without us having a lag time or downtime in our business, it's critical.
On-prem, you're still constrained by the physical. Exadata is a great machine, but when you run out of space, you have to get more. So the Autonomous Data Warehouse Cloud, to be able to scale very elastically is phenomenal.
Having that kind of analytics at the speed of thought, so that you can be interactive and go from into a question and answer session in real time, and you don't lose your train of thought, is absolutely important for them.
And one of the beauties of using advanced analytics is everything runs in the database.
So the ultimate goal for us is to have Oracle managing the database for us.
On that slide, one of the things we're seeing is, a lot of customers over the years had bought products like Teradata and Netezza to do their data warehouses. Those products are all now pretty much obsolete. We have a lot of customers moving those systems to our autonomous data warehouse and getting much, much better performance at much lower cost. That's one use case I definitely encourage you to take a look at. And then we have customers doing things like Oracle Business Intelligence on top of the database. We have some customers who have moved those systems to ADW, and those are working really well. Okay, so let's go to autonomous transaction processing. Again, what is this service about? Well, the use case is not just transaction processing, it's any kind of mixed workload where you're doing a combination of transactions and analytics, batch processing, reporting, etc. So this is a very general purpose service, which means the autonomous problem is, autonomous tuning, self-tuning is much, much harder in this environment. And so what you'll see here is, though, this system is really easy and it's very similar to autonomous data warehouse. We will automatically, provision the systems for you just based on number of CPUs, amount of storage, and we will give you a fully tuned transaction processing database. So here, of course, we're using the row store, not the column store. But it's on Exadata, just like autonomous data warehouse. It's very elastic, just like autonomous data warehouse. And the only real difference here is around the self-tuning. Since the self-tuning is much harder, the current version, the first version we ship, it has some self-tuning capability. You can use SQL plan management, things of that sort, Atom. But the full self-tuning is going to be coming out in a new release that's going to come out towards the, like I said, going beta now, will be production early next year. And so we're going to talk about that. But in this service, what we're providing the DBA is going to be more like an expert system to help the DBA be much more effective at tuning. If he wants to, he can use us to do the self-tuning. And if you have a department where they don't have DBAs, we're going to do a really good job of self-tuning. But if you have a DBA, he knows all the workload, he knows all the data better than anybody else could know. He's going to use our self-tuning more as an advisory function where he'll decide, if he wants to accept our recommendations or not. Okay. Use cases, just like what I mentioned, everything you run on Oracle databases that aren't pure analytic systems are a good fit for ATP. Okay, so here's what's coming next. The big thing we're coming out with is something we call ATP Dedicated. And what this is, if you are a big enterprise and you're like a big bank and you sort of like this notion of public cloud, but it makes you nervous that you're on this infrastructure that's shared with all your friends and neighbors kind of thing. Instead of a shared environment, which is what you get today in ADW and ATP, we are going to give you an environment that is highly isolated in the cloud. So we will give you your own private Exadata box, physical box in the cloud with its own network. We'll surround it in this thing we call a VCN, which is a virtual compute network or cloud network that gives you your own secure area in our cloud. And you essentially can create what I like calling your own isolated private cloud in our public cloud. And so we think a lot of the enterprise customers may prefer this kind of environment. Okay? As part of this dedicated infrastructure, this is the first place we're going to offer the 99.995% uptime SLA. You will get that as part of this environment if you want it. It'll be optional. Obviously, it'll cost a little extra for us to give you that kind of SLA. And another big thing is a lot of our customers are, like I said, they're somewhat nervous about going to public clouds. This is part of the solution, but some customers have reasons why they just have to run in their own data center. There are regulations they might have to worry about where the data about the citizens of a given country has to be in that country, for example. And those customers are using what we call Cloud at Customer. So Autonomous Database at Cloud at Customer is going to be available next year as well. And we think a lot of customers are going to look at that. And then finally, we'll talk about the self-tuning capability on the next slide. So let me go to that one. Okay, so sort of back to the analogy to self-driving cars. You know, in a self-driving car, you say, take me from where I am today to some other location. It does the work for you. You know, in the cloud with autonomous database, the equivalent is, you know, is a self-tuning database. You know, you just give us the query, and we figure out the best access plan for doing that query. And you can think of an access plan as sort of a route, you know, set of directions you go on when you're doing a self-driving car. And an index is sort of like a shortcut on the route. And the big thing our autonomous index creation or automatic index creation does, it sort of figures out by testing what are interesting indexes that maybe should be added that can make your queries run faster. And so what it is doing is basically an expert system. It is capturing all your workload. It's capturing, you know, all the data distributions for your data in the database. And if you want to, when you come up to our cloud, you can actually bring your existing workload with your existing plans with you. You know, we have a way of bringing that using things like SQL tuning sets, et cetera. And you can start with that, and then we will evolve your system from there then on. You know, as your system operates, we will try to figure out indexes that could be created to make things work better. We will actually, in the background, create indexes that we won't put in place yet. And then we will experiment with them. And then finally, when we're pretty confident that this index is going to make some collection of queries run faster, we will start putting it in action, and we will run it on your real production system. And so the next user that comes in and runs a certain query where we think that index is going to work, we're going to try it out for real in production, unbeknownst to you. And as long as the performance is really good, we will leave it in play. Now, of course, what happens if the performance regresses? It's not good, even though we thought it was going to be better. Well, today on-prem, what happens is you have all these users calling you up saying, hey, what's going on with my system? The performance is horrible. On the cloud, what's going to happen is we're going to notice immediately that this wasn't a good idea. We're going to go back to the old plan automatically for you, and we'll never try that ever again. So you'll just see this momentary glitch one time maybe. But the good news is, you know, as you know, 99.9% of the time, the optimizer actually chooses the right plan. And now we will automatically make sure in those rare occasions where it doesn't, those go away really fast. And so this nightmare about regressions when you move to new releases, et cetera, or do upgrades where the optimizer may put in a plan that's worse than before, we're going to deal with that now automatically for you as part of this service. Okay. Okay, so I mentioned earlier that CIOs really like autonomous database. What about the developers? Developers really like this concept as well. You know, in the past, developers, you know, they like really simple stuff, and so they gravitated towards simple database technologies like NoSQL technologies, for example, because they were so simple that they could install the software and they could maybe tune it, not really, but they thought they could, themselves and write some applications. Now with autonomous database, developers get the full power of Oracle running on an Exadata with full, you know, all the capabilities of Oracle there for them at the push of a button. They love this. There is no organization getting in their way of building very complex applications on the most sophisticated relational database out there, right? This is great. And they get, as we said, a full multi-model relational database. They don't need a special database for spatial and another database for key value lookups and another database for graph. We do all that in one place. So if you want to write a complicated application that uses all those things, which is not unusual. You know, everybody today is now doing spatial lookups in their relational databases. You know, everybody in the future will probably be doing graph analytics in their relational databases, et cetera. So this is a really nice environment for developers, and you know, definitely get the word out to your developers about this. I mean, this really changes the game for what databases developers should be using in your enterprises, right? Okay. And then, of course, the DBAs. Now, a lot of you are DBAs, and you know, you hear things like, oh, you know, the goal is to eliminate all human labor and all that. Well, For DBAs, it's actually pretty good here. So the big thing we're attacking here is a lot of the drudge work that you don't like doing. You know, how many of you really like applying patches? Not probably many. How many of you like doing upgrades? Yeah, they're painful. So you really like, I think, giving us that responsibility. The self-tuning part, as I said, for ATP is actually a very challenging problem. And I think DBAs can look at that as an expert system that's really going to empower them and make them more valuable to the company. And then, as I said, a lot of these tactical operations go away. So you now can be much more valuable to the business if you're a DBA, if you can now focus on things the business really values from you. You know, what is the right data model to build this application? You know, work with the development team to do application tuning of their data management applications, right? And you don't have to do this stuff that's more the drudge work, right? So even the DBAs, I think, are starting to come around here to understanding, you know, this is really good for them as well. Okay. So just to summarize, we talked about these three classes of users and what they think about autonomous database. CIOs really like lowering costs. They like lowering risk. You know, the fact you can take your existing Oracle databases and very easily move them to a cloud environment, whether it's cloud at customer or a public cloud, without rewriting those applications in any way, that's really powerful, right? That we take care of the cyber attacks and we do the patching for you. We take care of the SLA for the uptime. You know, that's golden for the business, right? Developers, we just talked about them. They really like the fact that they can just do their work on really powerful data management infrastructure with no mess, no fuss, no intervening organization that they have to work with. And of course, the DBAs have this opportunity now to become much more valuable and strategic to their business, get more involved in capturing value out of the data, not so much time needs to be spent on patching and upgrades, et cetera. Okay, so back to where we sort of were at the beginning. We think, you know, as you look forward to your journey to cloud, as you're modernizing your infrastructure, moving to a cloud environment, we think, you know, compute and storage are nice, they're important, but what's really important is your data, and it's your most valuable asset moving forward. And we really think with Autonomous Database, we have a really nice way that you can take all that existing data you have on-prem in your Oracle databases, move them to a modern cloud environment that includes not just Autonomous Database, but a very modern IaaS environment. And Larry Ellison's keynote today is going to talk about our IaaS and some of the very interesting characteristics it has. And so we think we have a really great place for you to take a look at. And as you look at strategic vendors for cloud, we think Oracle should really be on your short list to consider. And you know, we think we're a great place for managing and protecting all your data, not just on-prem, but also as you go to the cloud. Okay, thank you very much for coming.